All right, so we're going to look at the next part of this example 4. And if you remember, we found from the rational zero theorem and also Descartes' rule of signs that we only have the following rational zeros left, only the negative rational zeros, because we know that there are no positive rational zeros or zeros at all. So these are the only possibilities, the negative ones. So this is what we determined after the first two videos, that those are the possibilities. Now, what we need to do, and they go through this in the textbook, they go through synthetic division to determine if each of these are rational zeros. And they just mention which one worked. Now, what you'll notice is they mention -4 works. Now, the thing is, you'll have to test every one of these to make sure that they work. Until you find 4 of them. And so, or up to 4. We may have 0, 2, or 4 based on the Descartes' rule of signs. But now that could be pretty tedious, having to do synthetic division so many times. And what you're looking for is a remainder that is 0, because that will tell us if it will factor or not. If we have a remainder after using synthetic division, then we can't use that, and we have to continue on to a different rational zero. Okay, so that will make a little more sense once we move forward. But the thing is, I want to show you, this is called the remainder theorem. This was discussed in section 3.1 on the first slide, if you look at the PowerPoint, and I'll show you that really quickly. So we have the following, the rational zero theorem. I don't want to delete this because, or I don't want to show this for that long because I don't want it to stay here. So notice that we have polynomial p of x, well, that's the function we have, is divided by x minus c, divided by some, binomial like this. Then the remainder equals p of c. So that's the thing. We can evaluate a function at p of c, where c is one of these rational zeros that we have listed here. We can check each of these by plugging it into the function and seeing if it has a remainder. If it has a remainder, then it's no good. Meaning, when we evaluate the function, if it's not 0, then we know it's not going to work and it's not going to factor. So that will help us determine what to use synthetic division for. So this is a nice little tool that they don't talk about in example 4 in the textbook, but I'm telling you right now. So yeah, let's go ahead and evaluate a bunch of these using a calculator. I'm going to use Desmos. Desmos is nice for this. We've used Desmos before. I'm going to go ahead and delete this. We don't need this now. I just wanted to show you that. You may want to refer back to that back in section 3.1 PowerPoint. All right, so we have the following. This is Desmos. I have it shrinked up so I can have it on the right side of the screen. But what we want to do is input the function. So we'll have p of x equals, and then we'll enter in 3x raised to the 4th power. And then plus 23x to the 3rd power, plus 56x raised to the 2nd power, plus 52x plus 16. Let me double check I entered this in correctly. I believe so. All right, so this function is now in here. And what we want to do is we want to input values into this function. So I'm going to hit enter, and now p of x is now defined as what I just entered above here. Now I can enter values into this function by doing p and then plug a value in. So for example, I can plug in my first value for p over q, which is -1. So we'll evaluate this. And notice right over here on the right side, it'll say it's equal to 0. So we know that p of -1 is equal to 0. And that's good. That's what we want. We know that p of -1 is equal to 0, so that tells us that the remainder is going to be 0. And that's what that remainder theorem that I had up before was telling us. If we evaluate at the value, then the remainder is going to be 0 when we divide by x plus 1. Remember, it's x minus c, so you have to take the opposite sign. So if we divide by x plus 1, meaning if we do synthetic division with -1, then we'll have a remainder of 0. And that's what we're looking for. Now, notice that they used -4. So let's go ahead and enter in another value, -4. Notice that that is equal to 0. And that makes sense if you look at the textbook, and you'll notice that when they do synthetic division with -4, they got a remainder of 0. So we can see that also P of -4 works. That's also equal to 0. Now, this is nice because you want to know how to use synthetic division, but this is an alternative to using synthetic division. We can just use the remainder theorem, and it's a lot faster. Okay, so that has a remainder of 0. And let's look at -2. We skipped over -2, so let's go to P of -2. That also has P of -2 is equal to 0. You'll just want to go through the list and see which ones give you a remainder of 0. And let's look at the next one. We're finally gonna see one, but P of -8. Notice that this is equal to 3,696. So P of -8 is, all we really care about it is it's not equal to 0. So we can actually eliminate that from our list now. So you're just going to go through the list and figure out which ones give you 0, and that's what we want. So we don't actually have to go through synthetic division. If we use synthetic division and used, -8, and we use the synthetic division process, we'll notice that the remainder in the end will not be 0, and we just did all that work for nothing. Instead, we can just evaluate it and see if it works. All right, so it's an alternative to this. So we'll go ahead and continue on. Let's look at other values. So -16. P of -16. That's equal to, okay, so let's delete this really quick. P of -16 is not equal to 0, as we can see. I don't know if you caught that, but that's equal to 115,920. No good. P of -1/3 now. Is that equal or not equal? We'll see right now. -1/3. And that's equal to 4.07. That's not 0. And so those didn't work. P of -2/3. And this is going to work, I believe. Remember correctly, P of -2/3. That's equal to 0, as you can see. Yeah, it's equal to 0. You can see that right there. So that's equal to 0. And remember, before I mentioned this in the first video at the very beginning for this problem. Since we have a degree 4, then we can only have up to 4 zeros. And notice that we found them. We have 3 here and 1 down here. So we don't actually have to continue. We know that these will not work because we can only have up to 4 zeros. So that tells us that the zeros of our function, again, we're trying to find the zeros of our function are the values we plugged into the function. So that's -1, -2, -4, and -2/3. -1, -2, -4, -2/3. And we're done. So this is an alternative to using synthetic division. I'm going to show you how to use synthetic division just for one, but realize we're done. This is an alternative method, but I just want to show you how to work out synthetic division just so you know. All right, so let's look at the first one we found. Let's use -1, and we have 3, 23, 56. We're just using the coefficients, and they're all positive. So, and 16. And we'll see that we have a remainder of 0. So we have 3. -1 times 3 is -3. 23 plus -3 is 20. Then multiply up, -20. 56 minus 20 is 36. -1 is, so that's 30. -36. And then that's 16. -1 times 16 is -16. 16 minus 16 is 0. So we have a remainder of 0. So it divided the function evenly. And so we know that when we divide, so what we've just determined here is that x plus 1, that this function factors to x plus 1 times 3x cubed plus 20x plus 36x plus 16. So it factors to this. And then we would then use synthetic division again to use this to break this down even further. We can't break x plus 1 down any further, but we found a 0 from this, which is -1. So that's how we got our first 0. We would continue this process, and we would notice that this would factor down into this part of the function would factor down into x plus 2, x plus 4, and x plus 2/3 if we were to go further, and we would actually we would have a 3 out in front also, or it would end up being 3x plus 2. So anyways, you don't really need to know that part, but you'll want to be able to factor down a problem further and further using synthetic division. But I just used these results with the remaining -2, -4, and -2/3 to get this portion right here. But you'd use synthetic division to get this. And anyways, hopefully this process makes sense. I have this alternative because I really think this works a lot better and it's a lot faster. It's not necessarily better, but the reason I think it's better is because it's a lot faster. And if you prefer the synthetic division process, go ahead and use that process. It works also, but you'll notice that you may have to do a lot of synthetic divisions to be able to find results rather than just evaluating your function using like Desmos like I showed. So let me know if you have any concerns, anything with this video or any of the videos. I'll be more than happy to help.